how we can integrate FRDM MCXA153 with WS2812B, which is the intelligent control LED circuit. WS281B is basically they have an address which we can control the LED between the GRB. They call it green, red, and blue. So from here, this data sheet here, you say it is the WS281B is an RGB chip with a package of 50/50 component. Basically, it's a quite big component. It's SMD component. It has intelligent data latch circuit by signal which is 0 and 1 basically. So from here, this is the mechanical dimension of the WS2812B LED. So if you go down here, you can see from this, which is we interested to implement to our MCUXpresso code for FRDM MCXA153. So we have RGB, so there's the different model going on. For this, we have what I'm interested is the sequence chart. From here is 0 encode and 1 for the turning on the address based on the LED. And for the particular WS2812B, they only use the MOSI line. So the MISO line, it doesn't use. It is only use the MISO, which is DI MISO line. It doesn't use the DO MOSI line. So you can see from here we have a reset code which is 50 microsecond. If you go to my MCUXpresso IDE code, which I already implement my FRDM MCXA153 LP SPI eDMA, which I'm using from the example code. They have this, which I call already a reset code. They say a reset code is more than a 50 microsecond. So you see for my reset code, I already have a delay of STK delay at least microsecond, 50 microsecond from here, from the system core clock. So from here you can see the cycle is going on between the RGB. Hex FF, which is 255 in decimal, will turn on the red, and in middle is the green, and most left, the right is the blue. So this is the bit position for each GRB. They say based on the data sheet, GRB composition of 24 bit data between for the color. So you have the G 8-bit, R 8-bit as well, and blue 8-bit as well. So this way, there's how the code works. So it actually now is it have a bit 8-bit of going on, and we have this which is the pattern. This is bit between ternary operator for 0B110 or 0B100. Basically, is this. You can see for the pattern for this sequence chart. This is what this pattern is called, sequence chart. So we apply for the code. Then we can have a bit and buffer and bit position for each time is for turning on the between the G and R and B. So we have an encode B, encode byte for the green buffer and the bit position. Then you can get this from the example they have already provided for the FRDM MCXA153. You can get from the example there. Then from there you just try to build your code for the WS2812B code here. So from here, take the binary, just copy it. What you do is for example, I just paste it on my desktop. Okay, I just post it on my desktop, replace the file destination. Okay, it's already here. Next, we're gonna launch my link flash over here. Go to link flash. Then we browse the respective AXF file, which is this MCXA1531, because we only use one for this demonstration purpose for WS2812B LED. eDMA enhanced DMA. So we go ahead and program this. Make sure the probe and device is MCXA153. Then you can see my LED is there between the GRB, but the color is you have to tweak between all this delay and also the baud with the WS28 baud running in the 32 megahertz. This is the optimal way. I think it's most probably will work for the GRB LED on the WS2812B LED. So I think this is the most optimal. I would say 32 megahertz. I would say this is the most optimal for the 32 megahertz to run on the WS2812B LED. And yeah guys, that's it for this video. I'm going to show you how you can implement. Actually, you can import the examples from the FRDM MCXA. That's it for the video. Thanks guys for watching. See you next time. Bye.